Summer officially began this past Sunday, and as we always do when the seasons change, it's time to check in with our resident astronomer, Dr. Chris Palma from the Penn State Department of Astronomy and Astrophysics. He's also Associate Dean for undergraduate students in the Eberly College of Science. Good to see you again, Chris.
Thanks for having me. I love being here.
Well, when we last spoke 3 months ago, the big news was Mars. Perseverance had just landed on the planet. This time around, it's more about Venus. There was this clarification about a gas that may have signaled life in its clouds. And then NASA just announced 2 missions to study Venus. Can you give us an update on both of those topics?
Yeah, and I want to add Europe is planning to send a mission there as well. So the challenge with planetary science is we only have so many funds and only so much ability to send these probes. So lots of them have gone to Mars lately, but there's a lot of interest in Venus. And so, yeah, we're sending multiple probes there to really study the atmosphere in depth and to map the surface. And what we really want to learn is, why did Venus turn out so different than the Earth? And I'm really excited about that answer. But returning to the question about that other detection, so it wasn't the detection that was the problem, it was the interpretation, which is really hard, right? So there was a feature that was detected in the atmosphere that we thought might have been phosphine, a really exciting gas that might indicate life. But anytime you talk about life on another world, you really want to do a lot of work to verify that. And so what other folks have done is say, oh, that detection's not in dispute, but we disagree with the interpretation. We think that they were just misled by a more common gas in a different layer of the atmosphere that was masquerading as phosphine. So maybe not as exciting, but still interesting.
And it all comes back to extraordinary claims require extraordinary evidence.
Yes.
Now, your field depends a lot on observations from ground-based telescopes. And I've started to see articles suggesting that those observations could be negatively impacted by thousands of these mini satellites that are being put into orbit, for example, as part of SpaceX's Starlink internet service. What's your take on that?
That's a challenging one, right? So I've had folks tell me, like, oh, look, I see this string of satellites passing across the sky, and those are very visible, and they're showing up in images we're taking, and that's a problem. But astronomers don't want to stand in the way of progress. We want Starlink to succeed at things like providing satellite internet cheaply across the world, but we also want companies that are thinking about doing this to think about the sky as a common good, right? If no one's going to be able to stargaze without seeing these thousands of streaks of light, that's going to be a real problem. So we're just working hard. And I will say SpaceX has been taking this seriously, trying to figure out a solution that lets them achieve what they want to achieve, but doesn't ruin the sky.
Yeah. There's a similar issue in meteorology right now regarding satellite usage of certain frequency bands for cell phone communication as opposed to weather data communication.
Yeah.
So yeah, I know what you mean. Changing subjects a bit, I kid you occasionally about how some of your theories in astronomy require the existence of stuff we can't see. For example, this thing called dark matter. But now one of your colleagues has proposed a new way of kind of seeing that. Tell us about that.
Well, just because you can't see it doesn't mean it's not there. And the standard answer is, right, matter pulls on everything. And so the motions of objects depend on what's pulling them. And so what he did was use a computer to determine how the motions of thousands of galaxies are being affected by matter pulling on them. And he discovered there's lots of it where there's nothing visible to see. What's really great about that is mapping that out really lets us reproduce the history of the origin of those galaxies. And so that's why people do it. If we know where the matter is, we can figure out how it evolved and how it got there.
Yeah. Some other interesting research I saw from your department involves how solar systems are born, kind of blending observations with computer simulations, sort of like how we do things in meteorology.
Yep.
Tell us about that research.
Yeah. Well, the formation of planets can take millions of years, right? So you might say to yourself, well, how do we know? Well, we don't watch it over a million years, but what we can do is take an image with one telescope of a very young system, take another image of one after it formed, and then another one a billion years later. And then we can piece what happened together through the use of computer simulations, try to identify how do you go from that initial phase to that end phase. And that's what my colleagues did. What's really exciting about that is we're learning that planetary systems have evolved to look very different than our own. And so there are systems where you have one planet like this and another planet orbiting like that, whereas all of our planets orbit in a very flat distribution. And so it's really been interesting to learn that the universe has figured out many different ways to make planets, and we're not quite as unique as we thought.
Got it. And speaking of planets, and we only have about a minute left, I'll let you choose what you talk about, but I know there was a recent picture of one of the moons of Jupiter that you really wanted to mention. And then there's an opportunity to see Mercury this summer on a date that's easy to remember. Give us a little bit about that.
Yeah, sure. So let's talk about Mercury. Mercury is closer to the sun than us. And so I always tell people, if you want to see it, look for the sun. On July 4th, Mercury is just going to happen to rise in the eastern part of the sky right before sunrise. So if you're an early riser and you know where the sun usually pops up above the horizon from your location, if it's clear, look low in the east right before dawn. And if you see a faint little speck, you're seeing the planet Mercury. And that's one that's rare for people to see. So I really encourage people to try.
Right. So scope it out ahead of time, the days, and figure out exactly where on the horizon the sun rises. And then get up early on the 4th of July.
Yes.
Hey, Chris, thanks very much. Dr. Chris Palma, Penn State Department of Astronomy and Astrophysics. And we will be back in a moment with more.